what force could possibly cause the superheating of the corona? The answer will rock you. The hellish solar corona rages at millions of degrees. For centuries, scientists have been baffled how anything so far from the sun's core could still burn so hot. Recently, as improved satellites offered a closer view of the solar surface, clues began to emerge. Below the corona, the sun's surface is literally boiling.
The reason is that the entire surface of the sun is covered with convection cells, hot material from the inside of the sun that rises up through, reaches the surface, cools off by glowing, giving off sunlight, and then sinks back down. Each bubble of material that comes up is about the size of Texas. It spreads out across the surface, cools off, and sinks down in 5 minutes. So that's a tremendously violent process. Well, that's happening in literally almost a million places over the entire surface of the sun all the time, around the clock, 24/7.
This boiling isn't only violent, it's also extremely loud.
The sun is a tremendously loud place. If you could imagine covering the entire surface of the sun with speakers being driven as hard as the loudest rock concert you've ever been to, that would be comparable to how loud it really is on the surface of the sun.
The sun's churning surface creates enough sound energy to superheat the corona to millions of degrees. Scientists believe that a combination of these sound waves and energy from the sun's magnetic field is responsible for the extreme temperatures found in the corona. The only time you can actually see the corona from Earth is at the climax of one of the most dazzling displays in the solar system, a total solar eclipse. Before scientists understood them, these awe-inspiring events instilled only fear. The ancient Chinese believed that a dragon was devouring the sun. So what's really happening in a solar eclipse? In simplest terms, it's when the moon blocks our view of the sun.
Imagine that you're sitting in the movies watching very happily something going on the screen, and then somebody in the row in front of you comes across and blocks your view. In the movie theater, you might not want that person to come across in front of you, but at an eclipse, we're very lucky to have the moon come across the sun, and we're lucky to have it come right across the middle.
We're also lucky that the moon, although it's 400 times smaller than the sun, is also 400 times closer to us. This cosmic coincidence means that the two objects just happen to be the same apparent size in our sky, which allows for one to completely block out the other. This magnificent cosmic event only happens when the path of the moon intersects the line between the Earth and the sun. The moon's orbit is tilted slightly, about 5 degrees. If it wasn't, we would have an eclipse every month.
And then we'd be bored. But we're not bored because most months the moon goes above or below the place where the line goes from the Earth to the sun.
So instead of one every month, we get a total eclipse somewhere on Earth about once every year and a half. As the moon slides in front of the sun, it casts a shadow onto the Earth. The outer part, where the shadow is fainter, is called the penumbra. If you're standing within the swath traced by the penumbra as it moves along the Earth's surface, then you'll see only a partial eclipse. But travel to a spot within the path of the dark inner shadow called the umbra, and you'll experience the majesty of a total eclipse. There's another option if you can't travel to the path of totality. Wait in one place long enough, and a total eclipse will pass right over your head about once every 300 years. The sun, that shining star of our solar system, is capable of both astonishing beauty and ferocious violence. It seems impossible to believe, but it won't be around forever. Eventually, even the sun must die.
The sun has a fixed amount of fuel in its core. It is undergoing fusion at a rate that you can calculate. You say, here's the rate it's using its fuel. here's how much fuel you have. So it's a simple calculation to show when the sun will die. And that's in about 5 billion years.
Well, unfortunately, the sun will not go out with a bang. It is too small to erupt in supernova. However, stars do a peculiar thing. They're one of the few things around that get hotter as they cool off.
As it exhausts its hydrogen fuel, our nearest star will cool and gradually collapse under the force of gravity. Energy from this collapse will start heating up the core again to hundreds of millions of degrees, hot enough to start burning helium. Under the extra heat of the helium burning, the star will expand into a monstrous orb called a red giant.
It gets so big, it will engulf the entire orbits of Mercury, Venus, and Earth. You don't want to be around for that. You want to be planet hopping your way to safety long before this happens.
The Earth is likely to change its orbit slightly as the star expands so that it won't be engulfed. Still, talk about global warming, you wouldn't want to be there.
The outer layers of our sun will eventually become so unstable that they will fly off into space, leaving behind a small core about the size of the Earth.
So remember, we've shrunk most of the sun, which is 1 million miles across, to the size of the Earth, which is more like 6,000 miles across.
Our once great star reduced to a slowly cooling cinder.
And life as we know it on Earth will cease to exist. And that is the death of the sun.
All of this is bad news for the human race. But look on the bright side.
We've got 5 billion years to prepare for this disaster.
For now, humanity basks in the glow of a sun in the prime of its life. Science has uncovered many of the secrets of our nearest star, but we remain awed by its beauty and ever more wary of its wrath.